Hello guys, this is CodeNCode and this is Orac and LCM problem. This is a video editorial for the problem Orac and LCM taken from Codeforces div 2 round 641C. So the problem is we are given an array of integers of length, and there are n integers in the array, and then we have to create a new multiset. You can consider it as new array such that each element of the array T is equals to the LCM of every pair from first array, the input array. So, and then after you have the T array, you have to find the GCD of that. So if I show you the example, let's look at the second example. The input integers are 10, 24, 40 and 80. So if you see, the T array is this 120, 40 and so on, and how this was generated. The first number is actually LCM of 10 and 24. The second number is LCM of 10 and 40. The third number in T is LCM of 10 and 80, which is 80. Then 24 and 40, which is 120, 24 and 80, 240, and 40 and 80, 40. So for each single pair we take LCM, and that would serve as one of the element in T. After you get this, you have to find the GCD of it. So GCD is actually the biggest number which divides every single number in T. So we see 40 is the biggest number, or 40 is the largest number which divides every single number present in T. So 40 divides this, every single number. Finding GCD is easy. Just take the common, just take whatever you can common from every single number. You see, we can take 40 common, so of course 40 would be GCD. So how we will approach this problem? So suppose one advice for you guys, if you are solving number theory problem, try to think in terms of prime numbers. It helps mostly. It really helps most of the time, but not always. But yeah, it is a good idea to think in terms of prime number when you are working with number theory problem. So what we are going to do, we are taking the same example 10, 24, 40 and 80. So what we have done here, we have prime factorized each number. So 10 is 2 raised to the power 1 into 5 raised to the power 1. 24 is 2 raised to the power 3 into 3 raised to the power 1. So similarly for 40 and 80 we have prime factorized all of the numbers. The first question is, what happens when you take LCM of two numbers? First thing we have to observe this. If you take LCM of 10 and 24, 10 is 2 raised to the power 1 into 5 raised to the power 1, and 24 is 2 raised to the power 3 into 3 raised to the power 1. Now see, when you take LCM of two numbers, if there is a prime which is common to both numbers, like 2 is common to both the numbers 10 and 24, so in the answer we will have that in the answer, you see, in the first number we have 2 raised to the power 1, in the second number we have 2 raised to the power 3. In the answer, that is the LCM would have the highest of the both of these. So LCM would have 2 raised to the power 3, the prime with the highest power. So in first number we have power 1 of 2, in the second number we have power 3 of 2. So in the answer we would have power 3, which is the maximum of these two. And if there exists a prime in one number which is absent in the second number, then the whole number would be copied directly. Like if here it was 5 raised to the power 3, but here as we can see in 24 there is no 5 in prime factorization, so 5 raised to the power 3 will be copied directly. So you see, if any prime is common, then we take the we write down with the highest power. So 2 raised to the power 3 is written, 3 raised to the power 1 is present, prime 3 is present in second number but not in the first number, so 3 raised to the power 1 would be directly copied. Again 5 is present only in first number, not in the second number, that is why 5 raised to the power 1 will be directly copied. So this will be our answer. So this is how LCM works. And this was an important observation because this is going to help us observe what will be the solution. Later you'll see why that is important. Now for the same example, I've written T array as well, 120, 40, 80, 120, 240 and 80 for the same input array. This is their prime factorization. Now the question is, will prime P be present in the answer? Now we see for this input array, this is T, and for this T we already know this is second test case and answer of this is 40. So in 40 we know 2 and 4 exist, 2 and 5 exist. In the prime factorization of 40 which is your answer, 2 and 5 are the primes which are present. First we will ask what are the primes which are present in the answer, and then we will ask how many times those primes are present. Like in 40, 2 is present 3 times and 5 is present 1 time. So 2 into 2 into 2 into 5, that becomes 40. So first we will answer what primes are present in the answer, and then we will answer each prime how many times appear in the answer. So once we know these, once we can answer these two questions, then of course we can get the answer. Now for each single prime we'll ask the question. So you see the candidates are only those prime which are present here. 2, 5 and 3 are the only prime which are present in the input. The answer will never contain a prime which is not present in the input. This is very easy observation, right? So the only candidates which candidates are those which are present and which are 2, 3 and 5 for this test case. And we see in the answer we only have 2 and 5, we don't have 3. Why is that so? Now see, any prime which appears n minus 2 or less than number of times, that prime will not be present in the answer. Now you see 2 is appearing in all of the 4 numbers, so 2 is appearing n times in n numbers. 5 you see is appearing in 3 numbers, this and this, so 5 is appearing n minus 1 time, that is okay as well. But 3 is appearing only 1 time, which is n minus 3, which is less than equals to n minus 2. So if any prime is appearing n minus 2 or less than number of times, then it will not be present in the answer. The question is why? Try to pause the video and try to answer this question yourself. Now see, the reason is if some prime is present n minus 2 times or less numbers of times, what happens? There are 2 or more than number which does not contain that prime, right? When you take LCM of those two numbers, for example this and this, if you take LCM of these two numbers, then the number generated would be such a number that does not have this prime. For example, LCM of 10 and 40, which do not contain the prime 3, is equals to 40. Now in the prime factorization of 40 you won't find 3 because neither 10 nor 40 contains that prime, that is 3. So in their LCM 3 would not be present as well. If their LCM doesn't contain prime 3, so when you take their GCD, the GCD will not contain 3 as well, because GCD contains only those primes which are common to all of the numbers. But here we are able to generate a number such that it does not contain this prime. So that is why if prime P appears in n minus 2 numbers, which means it is leaving at least 2 numbers, and those 2 numbers doesn't contain this prime, and those 2 numbers will be able to generate a number which does not contain this prime. If that happens, then in the answer this prime won't be present. So now we know how to find whether prime P is present in answer or not. So for 2 we know it is appearing n times, so 2 will be there in the answer. 5 is appearing n minus 1 times or in n minus 1 numbers, so 5 will be there in answer as well. But 3 is less than equals to n minus 2 times, that is why 3 will not be there in the answer. So that is why the answer, which is 40, contains only primes 2 and 5. Fair enough. Let's continue and answer the question how many times 2 and 5 will appear, because we now know 2 and 5 are there in the answer, but we do not know how many times they will appear, because to get the complete answer it is important to know how many times prime 2 and 5 are appearing. We already know for that question 2 was appearing 3 times and 5 was appearing 1 time. But let's look at these two situations, because the number will either be present, a prime p will either be present n minus 1 times, or prime p will be present completely n times to be present in the answer, right? So let's look at these two conditions separately. First, let's analyze a condition where prime p is appearing n minus 1 times. We see here there are only two primes, 3 and 5. 5 is appearing n minus 1 times, 3 is appearing only 1 time. So of course 3 would not be present in the answer, but 5 will be present in the answer. First thing clear. Second thing, how many times 5 will be present there? So if you take out common out of all of these numbers, I've generated t for this input. If you take out common of all of these numbers, common factors among all of these numbers, then you'd find that common number is 5 itself. 5 only. 5 raised to power 1 will be your answer. So we are sure that okay, 5 raised to the power 1 will be the answer, but how to know how many times, because we cannot generate actually t and then take out the common, right? We can't do that, so we have to find another way. Another way is this: if any prime is appearing in n minus 1 numbers, then answer would contain p raised to power k. So if prime p is appearing in exactly n minus 1 numbers, then in answer we would have p raised to power k, where k is the smallest power of p present in any number. So you see, p, which means 5 is appearing 3 times, which is n minus 1 times. So first thing clear. So the answer would contain p raised to power k, where k is the smallest power which divides any number. So see, 5 raised to power 1 is here, so power 1, 5 raised to power 2, which means power 2, 5 raised to power 3, which is power 3. So 5 is here, 5 is having power 1, here 2, here 3. Smallest of all of them is 1, so the answer would contain 5 raised to power 1, and we know the answer of this is 5 raised to power 1. Why is that? And why that happens? Now see, we have to take common all of the factors to get the GCD, right? Now see, there since prime p is appearing n minus 1 in n minus 1 numbers, which means there exists a number which does not contain prime p, and we see here, yes, there is a number which does not contain prime 5. So what you can do, you can take LCM of these two, and the number that is generated, which is 15 here, the number that is generated will contain prime 5 as many times as it present here, which is in this number prime p will be present p raised to power k times, where k is the smallest, and here we see 5 is present 5 raised to power 1 time only, right? If you take common all of these, so you the minimum you are able to generate power of 5 is 1, which is present in the p raised to power k. So that is why when you take common, the minimum is 5 p raised to power k, the rest will be greater or equal to that. That is why when you take common, you would get p raised to power k. If this thing is not clear, take some other example, make sure that this thing is clear, because we are going to use this fact directly. If p any prime is appearing n minus 1 times, then in answer p raised to power k, p would be appearing k times, where k is the smallest power present in any number. Smallest power of p present in any number, right? So smallest power of p is 1 here. Here for prime 5 power is 2, here for prime 5 power 3. So smallest is 1. So in answer p raised to power 1, that is 5 raised to power 1 would be there. Now when prime p is appearing exactly n times, here we can see prime 5 is appearing in this, which means prime 5 is appearing in all of the numbers. Prime 5 is there in n numbers, right? If prime 5 or prime p is appearing in n numbers, then in the answer p raised to power k would be there, where k is the second smallest power of prime 5 or prime p itself. Now we see for 5 raised to power 1 power, for 5 power is 1, 2 and 3. In first number we have 5 power 1, in second number we have 5 raised to the power 2, and in third number we have 5 raised to the power 3. So we see that okay, power 2 is the second smallest power, so in answer we would have 5 raised to the power 2. If we take common out of this, you would get 25, which is 5 raised to the power 2. Again, the way we were able to get 5 raised to power 1, which was smallest, is same way we would be able to get 5 raised to power k, which is where k is second smallest, because this is every single number would have p raised to power k at least, because all of the number are having p in their prime factorization. So there will be the smallest one, which is this, and there will be the rest of the numbers. If you take LCM of this number with any of these, we already know 5 is common to them, so the LCM would generate a number where we are having maximum of power, right? Because for every single pair you take, 5 is present in all of the pairs, all of the numbers. So the LCM, if you take LCM of 5 and 25, the LCM would be 25, because the LCM contains highest power of that prime if prime p is common to both of them. Prime 5 is common to both of these two. That is why 5 raised to power 1 would never be present in any of the integers in the t. The minimum you would get is the second power. Second power, I mean second smallest power. That is why where when p is appearing exactly n times, p raised to power k would be present in the answer, where k is the second smallest power. Now if I show you the code to make things clear, here one important thing, I'll be using pb, which is pushback. This is a function used to insert element in the vector. So you see, primes is a vector. First of all, primes is vector of integer, so I'll be using it to store all of the primes up to 2 into 10 to the power 5, because in the input every integer a can be as large, input integer a can be as large as 2 into 10 to the power 5. So what I'm going to do, I'm going to generate all of the prime numbers up to 2 into 10 to the power 5. So vi is vector of int, here vi is vector of integer. So the primes is actually vector of integer to store all of the prime numbers up to 2 into 10 to the power 5. Now LLI is long int, LLI is long int. So this I'm using to take integer array input. This I'll be explaining in a moment. What is this? This is a map which stores for each prime number p, stores a vector of it for each power of this prime number which is present in the input. I'll be explaining this in a moment. So now init is a function which is there to generate all of the prime number up to 2 into 10 to the power 5 and store them in this primes vector. I'm using sieve here to generate all of the prime numbers up to 2 into 10 to the power 5. Now sieve I have already explained in my number theory playlist, so if you have no idea, just go and watch that lecture first. This is binary exponentiation to calculate a raised to power n, because we know that okay, if prime p is appearing n times, result contains p raised to power k. If prime p is appearing n minus 1, result contains p raised to power k, where k is smallest. So you need to calculate p raised to power 1 or p raised to power 2 and so on. For that I have written this power function, which is binary exponentiation to calculate a raised to power n in log n time. I have already explained this in my number theory playlist, so I'm not going into the details. Now we are reading n, which is present in the input, and after that we are reading each element present in the input. For each element that is AR of I am finding prime factorization of that number, because we need to find prime factorization of the number so that we can calculate for each prime. For each prime we can know how many times it is appearing, or for each prime we can know in how many numbers this is appearing, so that we can decide whether this prime is appearing exactly n times or n minus 1 time, or n minus 2 or less than number of time. So I'll be creating this, a map. So this was the input, this is prime factorization for each number, and this is the map, this is the purpose of the map. So now for prime 2, you see prime 2 is appearing in first number and power is 1, prime 2 is appearing in second number as well and power is 3, and again and power is 3 again, and again power is 4. So power of 2 is 1, 3, 3 and 4. So I am having, for each prime p, I am having a vector of their power. So when you take the size of this vector, it tells you the number of elements in which prime 2 is appearing. So we know prime 2 is appearing in four numbers. Here there is a typo, I'm sorry. For MP of 5 I should have only 3, because 5 is appearing in 3 numbers only with power 1 1 1. So 1 would be 3 times there. So and 3 is appearing in only one number and power is 1, so the vector contains only 1. So if you take the size of their vector, it tells you the number of number in which they are appearing. So 2 is appearing in 4 numbers, 3 is appearing in only one number, and 5 would appear in 3 numbers. This is a typo. There was only 3 ones. There are only 3 ones because 5 is appearing 3 times. So if you take the size of that, you would get 3, which indicates in how many numbers 5 is present. So this would help us to determine whether this prime exists in our answer or not. So for what I'm doing here, I am prime factorization, I am getting the prime factorization of this number AR of I. So for prime j, this is the count. So j raised to the power count present in j raised to the power count is present in the prime factorization of AR of I, right? So in prime number j, in the vector of prime j, I am inserting this count. So basically what I'm doing here, I am generating this map. Finally, one more thing, I've already explained prime factorization in my number theory playlist, so not going to explain this whole code here. Just remember, we are prime factorizing every single number, and also we are getting ready our map. So after that, what we will do, after our map is ready, we would find, we are calling init function, which does nothing but find all prime numbers up to 2 into 10 power 5. We initialize result with 1 because no matter what, result will be 1 at least. Now for each prime up to 2 into 10 power 5, we will see whether this exists in our answer or not. And there are 3 different conditions we have seen. If this prime is not present in the map itself, so that means this prime is not present in the input itself. You see, prime 2, 3 and 5 are present in the input. That is why the map would contain keys 2, 3 and 5. If the prime is not present in the input, which means the prime cannot be present in the answer. So mp.find p, which means we are checking whether prime p exists in map or not as key. If it returns and, mp of and, which means prime p doesn't exist. So if in the map prime p is not present as key, that means prime p cannot be present as answer. So we are continuing for the next iteration. Otherwise, if its size +1, if the vector size +1, like for 3 we see vector size +1 is 2, which is less than or equals to n minus 2. Sorry, which is strictly smaller than n, which means it is present n minus 2 times or less number of times, right? If that happens, we are continuing for the next iteration, which means this prime is not present in our answer because this prime is appearing in n minus 2 or less number of primes, and we have seen already, if that happens, this prime cannot be present in the answer. Now what we are doing, we are simply sorting the whole vector for this prime. The reason is this: we will see whether this prime is appearing exactly n times or whether this prime is appearing n minus 1 times. So if this prime is appearing n minus 1 time, then in the answer this prime p will be present the least number of times, right? So if any number, for example here 5 was appearing n minus 1 times, so 5 will be present there for p raised to power k, where k is smallest, so the power is smallest, so we are taking the smallest power. After sorting, the zeroth element in the vector would be the smallest. Otherwise, if the prime p is appearing exactly n times, then the answer would be multiplied with p raised to the power k, where k is second smallest, so index 1 would contain second smallest number after sorting. So this is how we solve this problem, and if you have any doubt or query, of course you can ask in the comment section. Maybe I missed something because while recording the video sometimes happens that I miss something. So of course you can ask in the comment section. And this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.